Alright, welcome to Unit 4. Within Unit 4, we're going to talk about graphing our trig functions. Now, we looked at our trig function in terms of the unit circle. So in this unit, we're going to unwrap those trig functions and plot them on a graph. Okay. Today, specifically, we're talking about our sine curve and unwrapping our sine curve from the unit circle, taking our unit circle and stretching it out, essentially. Okay. The sine curve is a periodic function, which means that we're going to see how long it takes to complete one cycle of that actual sine curve. Okay. Sorry, and what that means is a periodic function, it repeats. Every time we travel around the circle, our graph looks the same. Okay. Well, a period itself is the distance to complete one of those cycles. The period relates to our domain. Okay. It relates to our horizontal stretch and shrink as far as transformations goes. Okay. The amplitude, all right, relates to our range. Okay. The amplitude relates to our range. It relates to our vertical stretch and shrink. It's half of our range. Okay, if our range is from bottom to top, well, the amplitude is half of that distance. All right. Sick. Remember, the range is our x and our domain is our y values. Okay. Well, today we're talking about our sine curve. In our next video, we're going to talk about our cosine curve. Well, if you think about sine, all right, we think about the unit circle, right? Within our unit circle, okay, if I think about sine, here's my circle here. Okay. Let's talk about our domain and range first. All right. If I input any value in for sine on this unit circle, whether it's a positive number or if I go backwards and think about a negative number, I will always have an output. So our domain for sine is from negative infinity to infinity. Because I can go an infinite amount of times in the positive direction, and I can go an infinite amount of times in the negative direction and still have an output for sine. Similarly, our range, if you think about our range of sine, I start off at 0, I go up to 1, back down to 0, negative 1, and 0, and I repeat that. Okay, so our range is from negative 1 to 1. Well, that kind of makes sense. If you think about the sine of theta, okay, sine of theta is opposite over hypotenuse. Well, the hypotenuse is always going to be bigger than our opposite side. So no matter what, if I'm dividing a small number by a bigger number, it's going to be a value less than 1. Okay. So like we said, our range is related to our amplitude. Our amplitude is half of our range. Well, our range is from negative 1 to 1. You think about that on a number line. I'm traveling 2 units, so my amplitude is 1. Our period, which relates to our domain, when we think about one trip around the unit circle, if I start at 0, I go to pi over 2, pi, 3 pi over 2, and back to 2 pi. Our period is 2 pi. Okay, that's how long it takes to make one trip around the unit circle. That's how long it takes to make one sine graph. We're going to look at what one period of sine actually looks like after unwrapping our unit circle. We got this sick video here. This is pretty neat. Here we go. So we think about this as our unit circle here. All right, we're going to start at 0. Our unit circle here, point A is at 0. Okay, so let's play this puppy. So as as I rotate the unit circle, as our unit circle goes up to pi over 2 here, our sine curve goes to 1. As it comes back down to pi, all right, our sine curve hits 0. This is about 3.14. As our unit circle goes on 3 pi over 2, or in this figure, it's about 4.71, our sine curve hits its minimum of negative 1, and it goes back up to 6.28 or 2 pi, our sine curve returns back to 0. Okay. The thing about this is it's going to go on forever. All right, it's going to go on forever in the negative direction, and it's going to go on forever in our positive direction as well too. But our range will be from negative 1 to 1 for that. Okay. So what does that look like? Well, there are going to be 5 major points. If I start at 0, I know that my period was 2 pi, so that's going to be my last point. Okay. On this curve, our maximum here was about 1.57, which was pi over 2. We came back down to 0 at pi, or 3.14, which is pi. Went down to negative 1 at 4.71, which was 3 pi over 2. And we know that our period takes 2 pi. Okay. So we also know that our range was from, whoops, not negative 1 up top. Come on, Joe. From negative 1 to 1. Okay. So that means our graph is going to look something like this. Start at 0, go to 1, 0, negative 1, 0. And here's, oh, that's so bad. It's tough to draw this little thing. All right, so that's about what a sine curve looks like. That is considered to be, this is one period here. That's a period. Okay, let's label some other important things. Right here, all right, we know that this entire distance right here, that's considered our range. So if you remember, our amplitude is half the distance of our range. So right here, I'm going to write it as amp, as our amplitude. The amplitude determines how far I travel up from my midline. Now, what is the midline? Well, the midline is this imaginary line, right? Not imaginary, but it's this line right here. It's the middle line of your function, of your graph, okay? Where your function returns to. All right. This is going to come into play. It's going to be very important when we do a vertical movement, where we vertically move our graph up and down. All right. Well, our amplitude is our distance from our midline to our highest point, okay, or half of our range. All right. So all of these graphs relate to stretching and shrinking of transformation. That's why we discuss transformations first. All right. So if we think about this, what I want you to do is explain the stretch and shift, or stretch and shrink, of this transformation. So pause the video and do that. Okay. So you should have gone the horizontal stretch or shrink by a factor of 1/2, which means I'm going to divide all my x values by 1/2, or multiply them by 2, and then a vertical stretch by a factor of 3. All right. Well, this is very similar to our sine graph. All right. Our sine function has these values. Our generic sine function looks like this: a times the sine of bx, and we're going to add some more to that in a couple videos. But this number in front, which affects our range, all right, it affects our y, like it did here, okay? It's going to affect our y, our range, in our sine function. Well, remember, our range relates our amplitude. So our amplitude is going to be this a value, but I'm going to have to take the absolute value because we want every distance to be positive, okay? Our period was affected by our domain, okay, because it was a horizontal stretch or shrink. All right. You notice that there's this b value here being multiplied to x. Well, remember, when it's on the inside, you do the opposite of what you think. So instead of multiplying, I'm going to be dividing by b. Well, what am I dividing? I know that my period is 2 pi. I'm going to take 2 pi and divide it by b. My intervals, what do? They help us count. You're thinking, what are you talking about? And what I mean is, they help us count along these lines. Pi over 2, pi, 3 pi over 2, and 2 pi. They determine what these actual tick marks, what these values are. So, to determine these values, well, we notice we have 1, 2, 3, 4. I'm going to take my period and divide it by 4 for my intervals. All right. Well, let's try one. How about it? We're having fun, aren't you? Oh, yeah. Okay, so, wow. We're going to graph two periods of y equals 3 times the sine of x, or sine of 2x. All right. Our amplitude, okay, our amplitude, which is affected by our 3 here, okay. Remember, our amplitudes are a value, so I take the absolute value of 3, which is just 3. Our period, okay, our period here is affected by our x, or that 2. Remember, when it's on the inside, you do the opposite. So I'm going to take my original period, which is 2 pi, and divide that by 2 to get pi. Our intervals are determined by our period. So I take our period and divide it by 4. Some strategies for graphing the sine curve. Think about your midline. So you go from your midline to your max, to your midline, down to your min, and finish back at the midline. That's assuming that this value here is positive. Okay? So when I think about that, I first want to figure out, all right, well, my amplitude is 3. So my max is going to be 3, and my min is going to be negative 3. I start at the midline. My intervals are pi over 4, and we want to graph 2 periods, 1, 2, 3, 4, 1, 2, 3, 4. So I start at pi over 4. Okay, this is 2 pi over 4, or pi over 2, 3 pi over 4, pi, 5 pi over 4. It's getting tough to write. 6 pi over 4, which is 3 pi over 2. 7 pi over 4, I should get an award. And then 2 pi. Okay, well, where do I start? I start at my midline. I go out to my maximum, back down to the midline, down to my minimum, back to my midline. And then I do it all over again. Max, mid, minimum, mid. And boom. Connect. Ooh. Oh, not bad. Connect your dots. All right. That's pretty neat. Let's do another one. Here you notice we have a negative 1/4. Okay, the negative. The negative means exactly what you think it does. With the negative on the outside means I flip it over my x-axis. So I'm going to reflect, not flip. So I reflect over the x. Okay. The amplitude, I want you to fill this part out by yourself, actually. I want you to pause the video and fill that yourself. Okay, for your amplitude, absolute value of this number, so I got 1/4. Period. 2 pi over b. My b value is 1/2, technically. All right, so when I divide by a fraction, I multiply by the reciprocal. So 2 pi times 2, which is 4 pi. Intervals, 4 pi divided by 4, which is just pi. Okay, so I'm going to plot this and try to graph it, and I want you to do the same. All right, so when we graph this, normally we would go midline up to our maximum. But since there's this negative, I have to reflect it over my x. So I'm going to go to my minimum, back to my mid, up to my max, back to my mid, down to my minimum, midline, maximum, midline. All right, so remember I'm reflecting over the x, which means I'm going to go down to the minimum first. Let's see how this one works. Man, that's tough to draw with. We're going to have to roll with it, though. What the heck? There you go. All right, let's try the last one. Hold back your tears. Again, we have this negative. Pay attention to that negative. All right, so that means I'm going to reflect REF over my x. Okay, I want you to fill this part out yourself. Okay, and then we'll check it. All right, so my amplitude is the absolute value of my a value. So absolute value of -5 is 5. My period, this one's a little bit trickier. All right, being multiplied to x is pi over 3. So I'm dividing 2 pi by pi over 3. Remember, when you divide by a fraction, I multiply by its reciprocal. So 2 pi divided by 3 over pi. Pi's cancel. Period is 6, which is 6 radians. All right. Intervals, 6 divided by 4, 3 over 2, which is 1.5. So when you set up your graph, don't forget about the reflection, and check it in a minute. All right, so here's what my amplitude looks like. Here are my intervals lined out for two periods. So remember, I start at my midline. Since there is a reflection, the negative in front, I'm going to go down to the minimum, back to the midline, up to the max, midline, min, midline, maximum, midline. Wow. And then connect your dots. Let's see how this one goes. We're running out of time here. Okay, so this is our sine curve. In our next video, we're going to unwrap. Wow, we're going to unwrap our cosine curve. All right, so there's our sine curve. I hope you enjoyed that video. Hopefully my little connecting the dots gets a little bit better by the next one, but we'll see what happens.